Okay, before we move into the next topic of this first lecture, I take one more example from the previous topic to remind and to build the synchronization or the connection between the two topics. For example, what is the probability that time to download a file is less than 13.8 seconds? So x is 13.8. We want to know the probability that less than 13.8 when mean is 18 and standard deviation is 5. So we transform it into z unit by using the formula which we discussed before. X is 13.8 minus mu is 18 divided by 5. So it is minus 0.84. Now z equals to minus 0.84. So under the normal curve we draw z. Mean of z unit is always 0. Z is minus 0.84. So here we write minus 0.84. So we want to know less than 13.8, which means probability that z is less than minus 0.84. So less than means this area, we need to find this area. So when we will see the area under the curve in the table from minus infinity to this point minus 0.84, it will give us the probability. So let's see the table. So in the table you can see minus zero point 0.8 here in the vertical column, minus this is minus zero point 0.8 and 4 is here, so minus 0.84. So this is the value which is 0.2005. So the probability that z less than minus 0.84 is 0.2005. So if we convert it into the percentage, so 20% video takes time less than 13.8 seconds. So now 20% video takes time less than 13.8 seconds. Now we do the reverse process in the next topic. We do the reverse process, that what time takes video to download less than 20%. So to do so we need to transform the formula. We call it finding x value. So finding an x value associated with the known probabilities. Known probability mean we just did our last example where we did for the 20% probability. Known probability would be 20%. The formula was like x minus mu divided by sigma. We can take cross multiplication, it will be sigma times z. X minus mu, you can bring this mu to the other side, sigma times z plus mu equals to x. So this formula and this formula is same. To find x we use this formula. So to do so, these are the steps which we need to follow. Sketch the normal curve and then place the value of the mean and z-scale. Find the cumulative area less than x. Shade the area of interest. So let's do it. For example, in the next slide we do it. We need to find x. Probability is 20%, mu is 18, sigma is 5. So less than 20%. So less than 20%. So this whole is 100% or 1. This whole area, don't forget, remember this is 1, 0 is here. So 20% must be here. So this area is 20%, which means 0.2. So now we will do the reverse process. We will see again z value here corresponding to zero point 0. So here once again you can see, let x represents the time it takes to download an image file from the internet. Suppose x is normal with mean is given, standard deviation is 5. Find x such that 20% of download time are less than x. So here this is 20%, which means 0.2. So against 0.2 in the z table we will see the z value. So here you can see, now we will, before we used to see the value here in this column, and in this column where it matches we take this value, but now we will do the other way around. So we will see where is 0.20. If you cannot find 0.20 accurately, you can find the nearest numbers, but fortunately here you can see here it is 0.20, and this 0.20 is against minus 0.8 and 4. So z is minus 0.84. Now we are doing, as we are doing reverse process, so you can see we are going towards finding x. So z is minus 0.84. Now we will substitute the values into the formula. Mu was given 18, sigma was given 5, and we just figured out z, which is minus 0.84. If you solve this, so x is 13.8. So 20% of the values from the distribution with mean 18 and standard deviation 5 are less than 13.5.